In this video, we will be evaluating piecewise functions and finding the domain of a piecewise function. Our piecewise function is going to be f(x) equals x squared if x is less than 2, 6 if x equals 2, and 10 minus x if x is greater than 2 and x is less than or equal to 6. It may seem complicated, but all it is a split-up function.
Now, let's think about piecewise functions in terms of robots. Imagine you are programming a robot to cross one of 3 different pathways. You mark each pathway with an inequality in its code, such as x is less than 2. If you assign the robot the variable x is equal to 1, the robot will be able to go through this pathway, since 1 is less than 2. It will check this by first trying to go through every single pathway it is given. Since x does not equal 2, or is greater than 2 and less than or equal to 6, a robot only has one option for it to go through. On the way, however, since the pathway also dictates that the robot must also perform the operation x squared in order to confirm the robot actually went through the pathway and didn't encounter a bug, the robot must square its assigned number, which its solution also happens to be 1.
If x equals 10, however, f(x) would be undefined because 10 does not make any of the statements true. This can be shown as the robot not being able to cross any pathways given to it. The domain of our piecewise function is parentheses negative infinity, comma 6, bracket, because x is less than or equal to 6, and there aren't any other inequalities limiting the least value for x. Our domain right now is in interval notation. We use brackets if x can equal the number, or parentheses if x is less than or greater than x, and if x is infinity or negative infinity. Another way to write down domain would be x is less than or equal to 6. The domain can be represented in a line graph. First we draw the x is less than 2 line, then the x equals 2 point, and the x is greater than 2 and less than or equal to 6 line segment. This makes x equal to all real numbers up to 6. Even though there are open circles on the line from the x is less than 2 and x is greater than 2 functions, 2 is viable because x can equal to 2.
The domain of a function is basically all the x values that are used in the function. You can think of it as all the viable answers for a piecewise function, or all the pathways our robot can take.